So students, let us move to the next topic in P block elements. We'll start with oxygen family. Oxygen family. Okay. So what are the elements that come under this family? Oxygen, then sulfur, then selenium, tellurium, and polonium. Okay. You know the general configuration of these elements are Ns2 and P4. Okay. So nature of the metal, these elements, this is non-metal, this is also non-metal, then that is oxygen and sulfur, they are non-metals. Selenium, it is what? Metalloid. Then tellurium is also metalloid. Polonium is a poor metal, you can say, or it is a radioactive element. So generally we are concerned with the elements oxygen to tellurium, as this is a radioactive element. So the properties also will study from oxygen to tellurium only. Okay. Now how this occurs? Oxygen occurs as oxygen O2 and also ozone, which is present in the ozone layer. Then sulfur, it exists as S8, then S6 also, S4 and S2. Okay. These two, they are found as sulfides. This is found in thorium uranium decay, as it is a radioactive element. Okay. Now let us go further. What are the general configuration of these elements? Now general configuration is in general properties, we will see. First is atomic radius. What happens to the atomic radius when we go from oxygen, sulfur, selenium, tellurium and polonium? What happens? The atomic radius, it increases down the group. Why? Because there is increase in number of shells is increasing, and number of shells is increasing, so therefore the screening effect will also increase. Okay. Then next property is ionization enthalpy. And here we will also study about electron negativity, both, because both they depend upon the inversely proportional to the atomic size it is. So we have seen that the atomic radius increases down the group. So what will happen? These two properties, it will decrease down the group. Okay. Then electron enthalpy also, it decreases down the group, or we can say it becomes more and more negative down the group. Okay. Then about density, it also increases down the group, that is increases down the group, it increases. Okay. Then physical properties like boiling point and melting point, it also increases down the group. When we go down the group, it increases. So these are some of the general properties of these elements, that is the oxygen family. Now we will move to the chemical properties of these elements. chemical properties. Chemical properties. How it reacts with oxygen. First is reaction with first reaction with hydrogen we will take, then oxygen with hydrogen. So the compounds that it forms, they are like H2E, where E is equal to oxygen, sulfur, selenium, terrarium and polonium. So it will form H2O, H2S, H2SC, then H2TE and then H2PO. So we can call this as what? Hydrides. Now, what happens to the acidic character when we go down from top to bottom? So what you see that it increases down the group. Okay, why? You see that the oxygen, the size of the oxygen is less, then the size becomes more, means the size becomes bigger and bigger. Okay, so the bond between the oxygen, the hydrogen is having very small bond length. Suppose that this is the hydrogen atom. Hydrogen and oxygen atom, they are almost of the same similar size, so the bond length will be less. Then slowly and slowly the bond length will go on increasing. Thus, to give the hydrogen will be easier for the tellurium as compared to oxygen. So H plus tellurium releases H plus easily as compared to oxygen. That's why H2E is more acidic as compared to water. I hope you have understood. Now next topic. Next topic is reaction with oxygen. Reaction with oxygen. So what it will form? Oxides. Hydrogen with hydrogen forms hydrides. With oxygen it will form oxides, and it forms oxides of two types, EO2 and EO3. Okay. So if it forms, oxygen will not react with oxygen, so the first element will be sulfur. Sulfur will form sulfur dioxide, selenium dioxide, tellurium dioxide, and these are the stable oxides. And if it form the types EO3, then it will form SO3, SCO3 and TeO3. What you see there, these two are unstable. Okay. And in this you can see the sulfur, the oxidation state of this is +6 and here it is +4. That is, it can have -2 to +6 oxidation state compounds, oxides it can form. Now one question is there, that sulfur dioxide, it is more reducing than oxidizing. Means you can see that sulfur dioxide, it converts to sulfur trioxide. Here it is, sulfur is having +4, whereas here it is having +6. Means it wants to come to the +6 oxidation state as compared to +4 oxidation state. Okay, that's why therefore it reduces, therefore it acts as a reducing agent rather than oxidizing agent. Okay. And the oxidizing power of these elements, that is sulfur dioxide to tellurium oxide, it increases. Okay. Now reaction with halogens. So it will form what? Halides. Halogen which forms halides. So it can be in the form of EX6, EX4, EX2, and the stability of the halides is in the order fluorides are more stable than chloride, and then bromide, and then iodide. And among the hexahalides, hexafluorides, that's why is the only stable. Hexahalides means this. Here these fluorides are only stable. The hexafluorides, you know that you'll see what hexafluoride properties. Hexafluorides, they have octahedral structure, okay, and they are gases in nature, and SF6 is very stable due to steric hindrance reason, steric reason. Then EX4, here SF4 is gas, SEF4 is liquid, and TEF4 is solid. Then in EX2, you see that all forms of this, they are, that is except SC, all forms, that is dichlorides and trichlorides. SC does not form. Dichlorides and trichlorides or dichlorides and dibromides. Okay. Now monohalides are generally dimeric in nature. Monohalides, they are dimeric in nature, means they exist as S2F2, S2Cl2, SC2Br2, or S2Br2, yeah, SCCl2, and so on. Okay. Why? And they undergo disproportionation reaction. Okay, for example, SC2Cl2, it gives SCCl4 plus 3SC, where one gets reduced and the other gets oxidized. Okay, now we'll go to the next topic. Main topics are coming, that is, we will do the compounds of these families. First is oxygen, O2, dioxygen. You'll see preparation properties here. Preparation and properties. In lab, we prepare by heating KClO3. If you heat it in presence of MnO2, then you will get KCl plus 3O2. This is what potassium chlorate. Then if you heat silver oxide, you will get Ag plus oxygen. If you heat mercury oxide, then you will get Hg plus oxygen. If you take hydrogen peroxide, then also it readily decomposes to water and oxygen. Okay. In the large scale, you prepare it by from the electrolysis of water. You know that hydrogen will be collected at cathode and oxygen will be collected at anode. You have already studied the hydrolysis of water. Then properties. It is a colorless and odorless gas, you know that. Then it is highly soluble. Solubility in water is higher and liquefies at 90 Kelvin, freezes at 55 Kelvin, oxygen. And it has three isotopes, oxygen 16, oxygen 17 and oxygen 18. Three isotopes are there. Okay. Then let us see some reactions with metals and non-metals. It reacts nearly with all metals and non-metals except gold, platinum and some noble gas. It reacts with maximum metals and non-metals. Some examples: calcium when reacts with oxygen gives calcium oxide, aluminium with oxygen gives Al2O3. I'm not balancing the equation. Then phosphorus, the non-metal, it reacts with oxygen and form P4O10. C plus O2 is equal to CO2. Then some of the compounds of the metals like ZnS, if it reacts with oxygen it will form ZnO plus SO2. If CH4 reacts with oxygen it will form CO2 plus H2 and so on. So these are some of the reactions of the metals and the non-metals. Okay. Now you know that some of the uh, compounds of the vanadium and vanadium pentoxide, you know, it acts as a catalyst in the formation of sulfuric acid. This is step in the contact process of formation of sulfuric acid that we will see later. Okay. So subcompounds are catalytically oxidized. So this is a catalytic oxidation. Okay. Now next compound is, oxygen is finished. Next compound is ozone. The formula of ozone is what? O3. It is an allotropic form of oxygen, very much reactive. Too reactive to remain long time in the atmosphere. It generally converts into oxygen, O2. Okay. That is also, let us see the O3. No? Let us see the structure of ozone. It is having one double bond O and the other one will be single bond. The single bond will have how many? 6 electrons and the double bond will have 4 electrons. So this is the structure, and it can be written, its resonance structure can be written 6 electrons and here double bond means 4 electrons. So this is the resonating structure, and between the two resonating structure you can draw the high resonance hybrid like this, dot dot dot, oxygen oxygen. Okay. So the angle here is 117 degree and the bond length is equal to 128 picometer. As it is having resonance, it has equal bond length. Now preparation. You can prepare it from oxygen. Okay. So when dried stream of oxygen is passed through a silent electrical discharge, then you will get ozone, and its enthalpy is plus 142 kilomoles. Plus means it is requiring some energy. Okay. Now the properties of ozone. properties. Ozone, it is a pale blue color gas and it becomes violet color when it is heated. It is diamagnetic. It is a strong oxidizing agent and liberates nascent oxygen. Means O3 gives O2 plus oxygen. Okay. So let us see some of the reactions of this ozone, how it acts as an oxidizing agent. If we react it with lead sulfide, then it will be converted to sulfate plus oxygen. So here this is -2 and here the sulfur is having +6. So oxidation number is increasing, means oxidation is occurring here. Then Ki, it reacts and form I2. I2 can further react with ozone and form iodic acid, HiO3, oxoacid of iodine, you can see. So here also, here it is -1, it goes to 0. Oxidation occurs. It's increase in oxidation number. Fe2 plus will be converted to Fe3 plus. SN4 plus 2 plus will be converted to SN4 plus. Then if you react it with NO2, then it will form N2O5, means it goes from +4 oxidations to +5 oxidation state, means there is increase in oxidation number. That's why it is a oxidation reaction. Okay. Now the iodine which it liberates can be used to detect, means we are using this for the quantitative estimation of ozone. How? If we use sodium thio, means the hypo solution, and react it with iodine, it forms NaI and Na2S4O6. So here iodine is liberated, is measured by the reaction with this, and thus it is useful in quantitative estimation of the ozone. So this finishes the ozone also, and I end up here this lecture here.